So this is Calc Notes 4.4. We're going to talk about De Moivre's theorem. And what De Moivre's theorem is a shortcut for us to take complex numbers and raise them to powers. So for this example, if I had the complex number -1 plus I, and I want to raise it to the 10th power, that means I'd have to FOIL it. And I'd have to do this 10 times. Plus, let's see. And keep going on and on and on. So FOIL that, get an answer, and then multiply it by the next binomial, then get an answer, multiply that by the next binomial, and again, like I said, I'd have to use it 10 times. De Moivre's theorem is a shortcut. I don't have to do that. Here's what De Moivre's theorem says. If I have a number that is in trigonometric form, and I raise it to a certain power, let's say that power in this example would be 10, I can just take r times whatever that power is, times by the cosine of that power times the angle, theta, plus I times the sine of that power times the angle. So this is the formula that we're going to use to be a shortcut instead of having to FOIL this 10 times. So let's actually look at solving this problem using the formula. So looking at the formula, the things that I need to know out of that formula, I need to know what r is, I need to know what n is, and I need to know what theta is. So again, I need to know r, n, and theta. Let's find the easiest one first. N is whatever the power is, so it's to the nth power. In my problem it would be 10. R can be found by doing what we talked about in the previous lessons, taking the square root of a squared plus b squared, and theta can be found by doing the tangent inverse of b divided by a. So looking at my problem, I know my a is equal to -1, and my b is actually equal to a +1. So plugging that in to find r, I'm going to get -1 squared, which is 1, 1 squared is 1, so I would end up getting r to be the square root of 2. Finding theta, take the tangent inverse of b, which is 1, and divide it by -1. So plugging this into my calculator and making sure it's in degree mode, I end up with -45 degrees. Well, here's the problem. Remember, anytime we find theta, we want to make sure it's in the correct quadrant. So where would this point lie? If I made a quick sketch of it, if I go over -1 and up 1, I know that it's going to be in the second quadrant. This point would be. So this is not the correct quadrant. -45 degrees is in the fourth quadrant. So to find my angle, again, that would mean the reference angle right here would be 45 degrees. Write that a little bit neater. So I want to know the angle from here going all the way around to there. So if that's 45 degrees, I would just take 180 and subtract 45 to get 135 degrees. That makes sense because 135 degrees is between 90 degrees and 180. In other words, it's in the second quadrant. Okay, so I have the three things that I need. Let's go ahead and plug it into our form. So I'm just going to write the form down here. I think it's easier than to plug the numbers in once I have the form. So r was the square root of 2. I'm going to raise that to the 10th power. Then I'm going to times that by the cosine of 10 times 135 plus I sine of 10 times 135. Let's write it like this. So this really becomes the square root of 2 when I raise it to the 10th power is 32. Cosine of 1,350 degrees plus I sine of 1,350 degrees. So if the problem asks you to leave the answer in trigonometric form, remember this angle must be between 0 and 360 degrees, and that's not. So in order to get it to be between 0 and 360 degrees, I have to find the coterminal angle. So I'm just going to keep subtracting 360 degrees until I get it to be an angle that is between 0 and 360. So when I do that, I would keep subtracting until I find that its coterminal angle is actually 270 degrees. So this would be my answer if the problem said to leave it in trigonometric form. Okay, now it doesn't give me specific instructions, but remember one of the things I said is that if you're starting in standard form, you probably should give your final answer in standard form. So let's go to our unit circle and figure out what the cosine of 270 degrees is. The cosine of 270 is 0. The sine is -1. So really what I'm going to be doing is taking 32 and distributing that into this. So I'd get 32 minus 30, nope, I wouldn't get 32, would I? When I multiply by 0, I would get 0 minus 32i. That would be in standard form. I don't really have to write it as the 0, I could also just write it as -32i. And this would be my standard form. So I show you both ways. So depending on what the instructions say, you can write it in either trigonometric form or standard form. Our next problem says that we have a complex number that is in trigonometric form, and I want to raise it to the 8th power. So I know that my formula says this: r raised to the nth power times the cosine of n theta plus I sine of n theta. So again, the things that I need for this problem is I need an r, an n, and a theta. Well, when it's already in trigonometric form, which is r times the cosine of theta plus I times the sine of theta, you already have your r and your theta, and remember that n is really the power that you're raising it to. So in this problem, our n would be 8. Our r is this imaginary 1 that's out in the front here, so r is 1, and theta is 5/4 pi, or 5 pi over 4. So now plugging that into our problem here, we would take 1, raise it to the 8th power, times the cosine of n, which is 8, times 5 pi over 4, plus I times the sine of 8 times 5 pi over 4. So when I do this, 1 to the 8th power is 1. Cosine of, let's see, 8 times 5/4 pi would be 10 pi. So again, if I'm asked to give it in trig form, my theta must be between 0 and, in this case, because it's in radians, it's not going to be 360 degrees, it would be 2 pi. So I'm going to have to start subtracting 2 pi until I can get to a number that's between 0 and 2 pi. So I do it one time, I'd get to 8 pi. Do it again, that'd be 6 pi. Do it again, oops, subtract 2 pi again, I'd be at 4 pi. And do it one more time, I'd be at 2 pi. So the coterminal angle would be 2 pi. So I could say that my answer is 1 times the cosine of 2 pi plus I sine of 2 pi. Again, that would be my answer if I wanted it left in trigonometric form. Let me show you how to get the answer if it's in standard form. So in standard form, you would have to look at the unit circle and recognize that the cosine of 2 pi is 1. The sine of 2 pi is 0. And we still have this 1 on the outside we're multiplying it by. So we'd end up with 1 plus 0i, or that really is just 1. You could write it either way. That would be your answer for standard form. This would be your answer for trig form.